Good morning. So today we're going to be working on Lesson 5, Session 3. A reminder to make sure that you have your iReady lesson done and that you get your workbook pages 105 completed for your notes through 108. Your homework will be pages 109 and 110 in your Ready workbook, and a Google Doc version is available to you. So a reminder that a dilation is a transformation that makes a scale copy of a figure, which means it takes a shape and makes it either smaller or larger depending on what that scale factor is. And when you dilate a figure, you start from that point called the center of dilation. So like I mentioned, dilations either reduce it, which makes it smaller, or it enlarges it by making it bigger. A dilation is not a rigid transformation, and we know this because a rigid transformation does not change the size or the shape of a figure. However, a dilation does change the size, and therefore it is not a rigid transformation. So a dilated figure is similar to the original figure, and similar means that it's the same shape, but not necessarily the same size. So when a figure is similar, it will have congruent angles, and then it will have proportional side lengths. So all the side lengths will be multiplied by that same scale factor. So again, a dilated figure is similar because they're the same shape, but not necessarily the same size. So for our first example on page 105, we see that Ryan's teacher is drawing these two figures of A, B, C, D in blue and E, F, G, H in pink below in the coordinate plane, and we need to figure out what transformations we could use and sequence of transformations to map A, B, C, D onto E, F, G, H. So the first question we're going to ask ourselves are the figures the same size? If they are not the same size, that means we are using a dilation. If they are the same size, that means there's no dilation. We can see that A, B, C, D and E, F, G, H are two different sizes, so therefore there will be a dilation involved. The second question is, are the figures facing the same direction? If they are facing the same direction, that means we're just translating it, and if they are not facing the same direction, that means we are either rotating or reflecting it, since those two transformations will change its orientation, or in other words, the way it's facing. So we know that since they are different sizes, there are a dilation, and since they are facing different ways, there is either a rotation or reflection as well. So we can see that our dilation is going to be by a scale factor of 1/2, and we know this because we have to take our new side length. So we'll take side length FG, our longest one, which is 3. That corresponds with our longest one in our original, with a 6. So we have to do 3 divided by 6, and we find our scale factor is 1/2. So that means that we know that one of our transformations that we will be doing is we will be dilating our original figure by a scale factor of 1/2. So again, that's our first step. So we can see that when we dilate A, B, C, D with a scale factor of 1/2, it's going to take each of the coordinates and you multiply their x and y by that 1/2. So if our A was at -2, 2, you multiply each of those by 1/2. So -2 times 1/2 is -1. +2 times 1/2 is +1. So there would be our new A, and then we would do the same for B, C, and D. So this would be our dilated figure. The next step is that we are going to reflect it over the x-axis here. So that way we have our new A, B, C, D prime. So we have our original figure, we then dilate it, and then we reflected it over the x-axis to form this figure here. Remember, when you reflect over the x-axis, your x values will stay the same, but your y's will become their opposite. So for example, we had our point at -1, +1, will now be at -1, -1. So your y values switch. We can see we're not quite mapped onto our HEFG figure, which means there's one more step in our sequence, which is to reflect over the y-axis. So once we take that figure in green that we had from step 2 and reflect over the y-axis, we will see that it matches up with our figure HEFG. Remember that when we reflect over the y-axis, that's when your y values will stay the same, but your x's will become their opposites. Another way of doing it is again starting with that dilation of ABCD with that scale factor of 1/2, because we know we will need to dilate it in order to make it the same size as our final figure. And then from there, rotating that figure 180 degrees. So taking our ABCD prime figure and rotating it 180 degrees, we'll map it onto that final figure of HEFG. So that is another sequence of transformations we could do to go from ABCD to HEFG. So then another way of looking at, if you don't do it through graph, is another way is through algebraically. So one way is we could write down all of our coordinates of our original figure, A, B, C, D, with their x and y values for their ordered pairs. And we can see that we're at -2, 2 for A. After a rotation of 180 degrees, our x and y values become their opposites. So -2 becomes +2, and +2 becomes -2. Same for B, -2 becomes +2, +4 becomes -4. And we would do that for C and D as well. Then after that, we take these coordinates and multiply them by 1/2 for our dilation. So 2 times 1/2 is 1, -2 times 1/2 is -1, 2 times 1/2 is 1, -4 times 1/2 is -2. And that's where we get our final coordinates of EFGH. So that's another way of thinking about it algebraically, is when we rotate 180 degrees, our x and y values become -x, -y, or in other words, they're opposites. So if this was negative, it's now positive. If it was positive, it's now negative. And then we take those new points and we multiply each of their x and y's by 1/2 of our scale factor. Then we move on to the connect it, which is on page 107, question 1. It's asking us to give the details of the transformations we use. So like we discussed, we would take figure ABCD and reflect it across the x-axis, and then reflect across the y, and dilate with that scale factor of 1/2. So that's one way of doing it. The other way we discussed is we take that figure and rotate it 180 degrees, and then dilate using a scale factor of 1/2. Both ways will give us that final image of HEFG for our figure. So when it asks whether or not dilating ABCD or rotated matters, so we can see that dilating first would produce the image the same size and distance from the origin. So whether we rotated or dilated first, it would not matter because it would still give us our final image. However, this is not always the case because most often the order of transformations does matter, but just in this example, it does not. So another way you could map figure ABCD onto figure EFGH is you could dilate that figure with a scale factor of 1/2, then you could reflect across the y and then reflect across the x. So you could flip the order of which way you reflect it. That will still give you the same end result in this example. So as we can see, there are multiple sequences we could use to map figure ABCD onto figure EFGH. For question 4, it asks what is another way you could map it. So that suppose that EFGH is the original figure and figure ABCD is the final image. So this time we're trying to go from this figure to this figure. So what two transformations could we do? So in this case, we would want to do the opposite. So the opposite of a rotation of 180 degrees would still be a rotation of 180 degrees. So if you went 180 degrees clockwise, the opposite of that is 180 degrees counterclockwise. If we had a scale factor of 1/2, the opposite of that will be a scale factor of 2. So 1/2, you flip that and it's going to be a scale factor of 2. So again, if we wanted to go from the smaller to the bigger one, you would just change it. So you would do the opposites. So instead of 1/2, it's now 2. So you do the multiplicative inverse. And then instead of rotating 180 degrees clockwise, you would then rotate 180 degrees counterclockwise. We're going to skip question 5 and go to question 6. We see that we have the vertices of triangle ABC are located at 4, 8, 8, 0, and C is at -8, 4, and we need to figure out what sequence of transformations of triangle ABC could result in triangle A double prime, B double prime, C double prime, D double prime. And we have our multiple choice options, so we're going to go through each one individually. So the first one talks about rotating our original figure 90 degrees clockwise and then dilating with a scale factor of 4. We're going to do that step by step. So the first step is to plot our original triangle. So our A is at 4, 8, our B is at 8, 0, and our C is at negative 8, 4. So that's just plotting our original triangle. From there, it's asking us to rotate that triangle 90 degrees clockwise. So we end up with our new coordinates here. And then it wants us to dilate that figure with a scale factor of 4. We can see that since our scale factor is larger than 1, our figure would get larger when we need our final project to be smaller, so we know that A is incorrect. If we look at question B, again, we have our original figure here in red. It's starting by asking us to rotate 90 degrees counterclockwise, and when we do that, it moves to these points here. Then from there, ask us to dilate with a scale factor of 4. Again, we want our final project in blue here to be smaller, so if we have a scale factor greater than 1, we know it will just get larger, so it must not be correct either. Part C asks us to rotate 90 degrees clockwise and then dilate with a scale factor of 1/4. So this time we're going to take our red figure, which is our original points, and rotate 90 degrees clockwise so that we get this figure here. From there, we are going to dilate with a scale factor of 1/4. We know that a scale factor that is less than 1 will make the figure smaller, so we know that that is a possibility. So we'll go ahead and dilate our green figure with that scale factor of 1/4. And when we do that, we can see that it's the correct size of our final image, however, it's the wrong orientation. So C is also incorrect. Next, we try out part D. So again, we have our original figure in red here. We want to rotate it 90 degrees counterclockwise so that it moves to these points here. From there, it's asking us to dilate with that scale factor of 1/4. And when we do that, we know that means it's going to shrink and it will fit exactly onto our figure of B prime, B double prime, C double prime, A double prime. So that must mean that D is our correct final answer because it was moved to the correct orientation with that 90 degrees counterclockwise rotation, and it was made into the right size using that scale factor of 1/4. Our last problem has that pillar draws a rectangle of JKLM here in blue, and she performs two transformations on rectangle JKLM to form our new rectangle of J double prime, K double prime, L double prime, M double prime. Part A asks what sequence of transformations could Pylar have performed? So again, that first question we need to talk about are they the same size? If they're the same size, that means that they are not dilated, and if they are not the same size, that means they were dilated. So as we can see, our original figure here in blue is much larger than our figure here in pink, which means there is a dilation. So that means that one of our transformations will be a dilation. The next question asks, are the figures in the same orientation? If they are, that means that there is a translation. So as we can see, our J is in our top left corner here, and our J double prime is still in our top left corner, which means that our other transformation is a translation. So we know that our two types of transformations we need to use are a dilation and a translation. So first we need to figure out what our dilation would be. So then we would take our original points of 2, -2, and then 1, 4, and divide our new divided by our old in order to find our scale factor, which we see to be 1/2. You could also do it by the side length, so you can see that our height here is 4 of our original, and our height here is 2 for our new. So we take our new height of 2 divided by our original height of 4 to do 2 divided by 4, which is 1/2. So that means we know our dilation must be 1/2. So it's going to shrink to be this size. From there, we have to see how many units we need to move it up. And we see that once we dilate the figure with that scale factor of 1/2, we then have to translate it 5 units up in order to match right on top of this J double prime, K double prime, L double prime, M double prime. So those would be our two different types of transformations. The next part says, could Pylar have performed the same two transformations in reverse order to form it? And so for this example, we can see that no, if he did it in a different order, it would not go onto the same final image, which is why the order does affect that final image and why it is important that we do our sequence of transformations in the order that it tells us to. Lastly, your homework is going to be pages 109 and 110 in your book. That's going to be due tomorrow, November 12th at 9 a.m. It is 5 questions long. If you have any questions, you can always email me and reach out to me. Other than that, have a great day.